Brought to you by Curious Brain then. Okay, so let's do this. Just get everything set. Not that. Okay. All right. So we'll make some observations. I said I need your assistance earlier. Hold it, not drop it.
That's why your third string wide receiver.
Okay, so shh, patient. Hey, look at this.
I watched this video on your YouTube channel.
Oh yeah.
Yeah, so it was. So you're ready. Okay, well, now this is going to go up well. So all right. So what is this?
A T.
Helicopter.
A helicopter. So what can we measure?
The length of the T. The length.
All right. Well, okay. What? All right. Right now, what can you measure?
Oh, the length of the wings.
There. Okay. Something else.
The weight.
All right, but we say mass, so a mass.
Oh.
Okay. And all right, so let's try this. I've already warned these people ahead of time.
Yeah.
All right. So can you move that? All right. So. We didn't have an earthquake. We're not in California. We need some help. Well, that's definitely going up now. Okay. And so assume
Uh-oh, you did it wrong.
all right.
Get it.
Well, let's assume I did 3. All right. So.
Could you just have done it standing?
Okay. All right. So, is there numbers I can get from that measurement?
Yeah.
The time it took to fall and the height in which I started. One of them which should be the same every single time. Constant.
And the gravity.
How long it takes for it to start spinning.
Right? And we could have done that. We'll just say from the distance it traveled and how long it traveled. That's called velocity. So the speed.
Or the gravity.
Huh?
Like gravity. Hold on.
Well, yeah, we're not really testing gravity. This is what we're gonna test. So, have we seen an independent variable yet? You just saw 3 times, 3 trials. Okay. Every trial is something that can be measured. Yeah.
The distance from where it dropped.
Okay. But is that an independent variable, or is that just the distance from when it dropped? Was it the same every single time?
No.
I tried to hold it from the ceiling and let go, right?
Yeah.
So we'll assume that was the same. And it's going to be the same for this whole thing. Now, what am I doing now?
Holding it.
Putting a weight on it.
Adding
made it-
weight.
Adding mass.
Increasing mass. I'm making an intentional change. Okay? So I'm making an intentional change. Let's talk about this. All right? So you have your paper. Let's label this. Do you notice the first thing on the paper versus what we're going to label here is different? This is just order of terms. So let's talk about this one first. It's purposely changed. What I want to do is give you some other lingo, some other language to help you when you're doing word problems. All right? See, what we're going to do next is we're going to use the back of this handout, and we're going to try and figure out what all these people are doing, and we want to be able to identify. We want to be able to identify the IV, the DV, the control. Okay? So let's go back to this. All right. It's purposely changed. Here's another buzzword. Now, before we do this, it won't be back to like that. So, before we do this, I want you to understand how I write it on here versus how you write on your paper may differ. I may abbreviate. But you don't want to get your notes, get home and have it look, well, what does that mean? So write it all out. Maybe write it underneath all this. I'm going to write it on top just because I want people to see. So let's try and write this stuff. So a purposeful change. Okay, you can also call it a intentional change. And my apologies for the bad handwriting, but an intentional change, a purposeful change, intentional change. And there's actually one more that you'll see over here in the dependent variable description. Okay, so what I measured is I could have measured the mass, and then I can measure the mass afterwards, so I can record, hey, here it is with one paper clip, here it is with two paper clips, and on down the line. Here is with no paper clips. And for that. Okay, so let's do a dependent variable next. Okay, the dependent variable, this is the key thing. It responds to the manipulated change. Hey, is manipulated change another name for something else?
Intentional change.
It's another way of saying intentional change. So here's your another buzzword: purposeful change, intentional change, manipulated changes are all ways of describing IV. When you look at word problems, they'll say, "Hey, this person set this up. They organized this. You know, if someone's doing, as Mr. Matheny said, the I change." Okay. Of course, when you're writing a formal paper, you never use first person. Okay. Now let's jump down here to. Let's do control next. It's not in the order of the paper, but so let's talk about control. To be honest, you guys have not seen the IV in action yet, based on my helicopter. What did you just witness?
Constant.
You saw me starting at the constant, dropping it 3 times, and then I made an intentional change. So I did the experiment without the intentional change.
So you did repeated trials.
I did repeated trials. True.
It's called something.
Control.
It's the control. So what you just saw as we videoed, you saw the control in action. Now we'll see the control, we'll see the intentional change in a moment. But we'll have to make a prediction. You notice we haven't even talked about hypothesis yet? Because remember, recognize a problem, organize, come up with a way of doing a hypothesis, which requires that you know IV and DV. Okay, so the standard of comparison. This isn't really defining. This little thing right here is not defining control. It's telling you how you use it. Do you realize this is not a definition of control? It's showing you how you use it. The whole purpose is to have a standard of comparison. But let's write one buzzword or phrase to help you discriminate between control and the other experimental design terms. Okay, which would be, I'll go back to blue. It's like without, you should write without, I'm writing W/O, without the IV. Without the IV. Doing the experiment without the IV.
It's without the change.
Without the change. So what you guys just saw me do was the control. Does this make sense?
Yeah.
Alright, so now let's go up to here. Hypothesis. I'll go to red for that. Alright, so educated guess. I would like to say a prediction. A prediction about or as to the relationship between variables. What are the variables?
The helicopter.
What are the variables?
Oh, the independent GT.
Right? So, a relationship between variables, meaning the IV on the DV. Does that make sense? So,
Can you repeat it?
it's, what is it? It's a prediction of the relationship between variables, meaning the relationship or of the IV on the DV. The DV is dependent on the change. That if there's going to be an increase or decrease in the helicopter speed, that's going to be dependent on me adding the paper clips. Adding the paper clips is the IV. That make sense? Okay. So let's do this. Let's get a prediction, and then we'll test our hypothesis. We've just done all the experimental design except for testing. Okay, so give me a hypothesis. Yes.
That when you add the paper clip, it's heavier, so it'll fall down faster.
Okay. You said it's heavier. Isn't that obvious?
Mass, more mass.
Right. So how about when you increase the mass?
It will.
The quicker it
We'll call it.
The quicker? What quicker? What?
goes down.
The
What's it?
velocity.
That thing.
This is called a helicopter.
The
Oh.
quicker the more velocity.
All right. You guys are all saying correct, but let's make it very formal. Jane.
Oh, sorry, I was stretching my back.
Scott, give me a hypothesis.
Oh, well, okay. I'm going to guess that it will go faster now.
I'm going to guess it will go faster now. Now, a true hypothesis should state the IV and the DV. So the IV again is what? You're going to tell us, but let me get the class. The IV is what? And
And if the paper clips are added, then the velocity of the helicopter will increase.
okay, so he's saying if you increase the mass, the velocity of this will increase. That is a question that we can test, which is what a hypothesis is. So, my little assistant here, my reluctant assistant. All right, so we just tested it. No, we tested it before. Do you remember how fast it went? Let's see. Does it go faster?
Not noticeably.
No.
Try one.
It's not noticeable.
Now you can take the paper clip off if you
No,
to refresh your memory.
Who keeps saying that?
Angel.
Okay. It takes longer to start spinning, but once it starts spinning, now guys, all that stuff would be part of your discussion. You're elaborating on your conclusion. So, I forgot to mention one thing. Constant. Factors that stay the same but has a fixed value. Okay, I just crossed out the word. Has a fixed value. You need to understand that it's the one important constant in this experiment was what?
The paperclip.
No, that was the idea.
Oh, and the where it started from.
The start point. The most important one was the start point, because if I started, actually, let's film this real quick. Let's go back to where. I'm not going to climb back up there, but if I started up there and then I started down here and I started down here, that'd be bad science. My results were not conclusive, not because they're done properly, but it was bad science. If I'm going to increase the mass, I need to keep the distance the same. I can do another experiment where I keep the same mass and I do different levels. They're all a whole bunch of experiments in the realm of effects of manipulations on helicopter speed. That's kind of how the paper could be written. Right? So you can have multiple experiments and you can change something. But my important thing for you to understand is a constant can easily become a variable. Students always want to list the most important constant. But if you don't list a value, if this was a quiz, and let's say that's 8 feet, and you said the ceiling or the starting point, and you didn't say that the starting point was 8 feet, we take points off. And to emphasize, the most important constant is one that could easily become a variable and affect your results. You're never testing those two variables at the same time. All right? I think I'm gonna go and stop this now. So.